Semiconductor Packaging. John D. Thomas, Alex Ruth. Book 6, Section 2, Chapter 2, Topic 4. Evolution of Advanced Packaging Technologies in Electronics, a 3-decade journey. Introduction. In the past 3 decades, the landscape of electronics manufacturing has been revolutionized by advanced packaging technologies. These innovations have not only facilitated higher levels of integration but also paved the way for enhanced performance and functionality in electronic devices. From the advent of ball grid arrays, BGAs, to the emergence of system-in-package (SIP) solutions, the evolution of packaging technologies has been instrumental in shaping the modern electronics industry. This overview delves into the key advancements in packaging technologies over the last 30 years, exploring their impact on various electronic devices such as smartphones, tablets, wearable gadgets, and IoT sensors. 1. Ball grid array, BGA. The introduction of ball grid array, BGA, packaging in the 1990s marked a significant departure from traditional packaging methods. BGAs replaced the conventional pin grid array, PGA, with solder balls arranged in a grid pattern on the underside of the package. This design not only simplified the manufacturing process but also offered improved electrical performance and thermal characteristics. By eliminating the need for through-hole connections, BGAs enabled higher component density on circuit boards, paving the way for smaller and more efficient electronic devices. 2. Chip-on-board, COB. Chip-on-board, COB, packaging emerged as a cost-effective solution for embedding semiconductor chips directly onto circuit boards. In COB technology, bare semiconductor chips are mounted directly onto the substrate, allowing for compact and lightweight designs. COB offers several advantages including reduced package size, improved thermal performance, and enhanced reliability due to shorter interconnection lengths. This packaging technique found widespread applications in consumer electronics, particularly in devices where space constraints and cost efficiency were critical factors. 3. Flip chip technology. Flip chip technology revolutionized the semiconductor packaging industry by enabling direct electrical connections between the chip and the substrate. Unlike conventional wire bonding techniques, flip chip bonding involves flipping the semiconductor chip upside down and connecting it to the substrate using solder bumps. This approach offers numerous benefits such as shorter interconnection lengths, improved electrical performance, and enhanced thermal dissipation. Flip chip technology became increasingly popular in high-performance computing, networking, and telecommunications applications, where reliability and signal integrity were paramount. 4. System-in-package, SIP. System-in-package, SIP, technology represents the pinnacle of advanced packaging, offering unparalleled levels of integration and functionality. SIP involves the integration of multiple chips, passive components, and subsystems into a single package, thereby creating highly compact and feature-rich electronic systems. By combining diverse functionalities such as processing, memory, and communication modules within a single package, SIP solutions enable the development of multifunctional devices with smaller form factors and lower power consumption. This technology has played a crucial role in the advancement of smartphones, tablets, wearable devices, and IoT sensors, facilitating seamless connectivity and enhanced user experiences. Thanks for watching. Please like, share, and subscribe.